Matthews Gatos here. In this video, we're going to take what we've learned about inverse trig functions and now find the derivatives. So I'm not just going to give you what the derivatives are because I don't think there's any value in saying, here's the equation, use it, don't ask any questions. So I want to prove to you where these derivatives come from. So the first thing that I'm going to do is I'm going to borrow from all the derivatives that we already know. We know how to take the derivative of sine, cosine, tangent, and their reciprocal trig functions. Let's start with sine inverse. So I'm simply going to let y represent sine inverse of x. I do that because I want to be able to take the sine of both sides. I'm really trying to get rid of that sine inverse. So take the sine of both sides. There we go. So I have the sine of y is equal to, now sine and sine inverse, those are inverse operations to one another. They cancel each other out. You're just left with x. So sine of some angle y is equal to x. Now it's positive, so I'm going to draw it in quadrant number 1. So here's angle y. Sine is x, which is really x over 1. So opposite over hypotenuse is 1. So to find my other side, I just use Pythagorean Theorem. C squared minus b squared equals a squared. So 1 minus x squared will equal a squared. So a is equal to plus or minus, but in quadrant 1 it's only positive, 1 minus x squared. So I know that this side here is 1 minus x squared. Okay, now I'm ready to go. So now that I have my sine inverse gone, I just have sine of y is equal to x. We're just going to take the derivative of both sides with respect to x. So the derivative of this side and the derivative of this side. Okay, so derivative of sine. We know the derivative of sine is cosine. So it'll be cosine of angle y, but it's with respect to x, so the derivative of y with respect to x is y prime. Equal to, on the other side, the derivative of x is just 1. So we want to get y prime by itself. So y prime is equal to 1 over cosine of angle y. Okay, well we can go to our picture of y and figure out what the cosine is. Now, if I do y prime is 1 over cosine y, that really means y prime is 1 over cos is secant of y. So secant of y, look at your picture. Cosine is adjacent over hypotenuse, so secant will be hypotenuse over adjacent. So that means that y prime is going to equal to, so cosine again is adjacent over hypotenuse, so secant will be hypotenuse over adjacent, which is 1 over the root of 1 minus x squared. And that's what y prime is. Well, remember that y was sine x, so y prime would be the derivative of sine inverse x. So the derivative of sine inverse x is just 1 over the root of 1 minus x squared. Again, because y was sine inverse, and y prime would therefore be the derivative of sine inverse. So now we know the derivative of sine inverse, 1 over the root of 1 minus x squared. Let's move on and do cosine. Okay, so in this one here, similar thing, we're going to do the derivative of cos inverse of x. So we don't want to work with cos inverse of x because we don't know the derivative of that. We're trying to prove it. So again, similarly, I'm going to let y equal to the cos inverse of x, and I'm just going to take the cosine of both sides. So the cosine of y is equal to the cosine of the cos inverse of x. So cos of y is going to equal to, cos and cos inverse are inverse trig functions, so they can't, inverse operations, so they cancel each other out, is just equal to x. Okay, so now that I know that, cosine is positive, and positive is in quadrant number 1. So let's draw that angle there. Cosine is adjacent over hypotenuse, so x over 1. So I can use Pythagorean Theorem, c squared minus a squared equals b squared. So 1 minus x squared is equal to b squared. So b is equal to plus or minus, but in quadrant number 1, it's just plus 1 minus x squared. So the root of 1 minus x squared. Okay, so now that we've got our cos inverse gone, we have just cos of y. We can take the derivative of both sides with respect to x. So the derivative of cosine y is equal to the derivative of x. Okay, so we know the derivative of cosine is sine, but because it's a c function, it's going to be negative sine y, and then multiply by y prime, because it's not just x. And then that will equal to the derivative of x with respect to x is just equal to 1. Okay, so let's get y prime by itself. So y prime is negative 1 over the sine of y. So 1 over sine is the same as cosecant. So this means that y prime is equal to negative cosecant of y. So let's figure out what that is. Go to our picture here. This is our angle y. Now sine is opposite over hypotenuse. So cosecant will be hypotenuse over opposite, but negative. Okay, so it's going to be negative 1 over the root of 1 minus x squared. Now, y was the cos inverse of x, so y prime will be the derivative of cos inverse of x. So now we know that the derivative of cos inverse of x is equal to negative 1 over the root of 1 minus x squared. So again, they are the same. Cosine and sine are the same. The only difference is that cosine, because it's a c function, the derivative of cos inverse will be negative. Okay, so that's sine inverse and cos inverse. Let's finish off with tan inverse, and then we can get going on some questions. Okay, so to find the derivative of tan inverse of x, same process. I'm going to let y be tan inverse and take the derivative of y instead of tan inverse of x. So let's do the tan of both sides. That's the only way I can get rid of my tan inverse. So I have tan of y is equal to tan and tan inverse, inverse operations. They cancel each other out, so you're just left with x. So tan is positive. That occurs in quadrant number 1. So let's sketch our angle. Now this one's a little different. So there's y. Tan is x. X is x over 1. So that's opposite over adjacent. So to figure out what my hypotenuse is, I just do a squared plus b squared equals c squared. So that's 1 plus x squared equals c squared. And then c is equal to plus or minus, but since c in this case represents a hypotenuse, it's only positive. Okay, perfect. So now that we've done that, let's take the derivative of both sides. So the derivative with respect to x of tan y equals to the derivative with respect to x of x. Okay, so I know the derivative of tan is secant squared. So I'll do secant squared of y, and then the derivative of y with respect to x, don't forget your chain rule, is y prime, equals to the derivative of x with respect to x is just 1. So isolating for y prime, I know that's 1 over secant squared of, nope, not x, y. There we go. Okay, so what I know about secant squared, 1 over secant squared would be the same as tan squared. So that means that y prime is equal to, so 1 over secant squared. No, let me say that again. Secant squared is the same as the reciprocal of cos squared. So 1 over secant squared would actually be cos squared y. I'm just trying to avoid doing some fractions. Okay, so looking at my diagram, cosine is adjacent over hypotenuse. So this will be 1 over the root of 1 plus x squared all squared, which is really equal to just 1 over 1 plus x squared, because the square and the square root cancel. Okay, so if y was equal to tan inverse, I now know what y prime is, which is the derivative of tan inverse. And that will just be 1 over 1 plus x squared. So we have now proven the derivatives of sine inverse, cos inverse, and tan inverse. Let's just put those all together so we can see how they're all related. So the derivative of sine inverse of x, that was the first one that we did. And we saw that that was 1 over the root of 1 minus x squared. Okay, then we did the derivative with respect to x of cos inverse of x, and we proved that it was the same thing. It's just because it's a c function, it is negative. And then the derivative of tan inverse of x is what we just finished, and we proved that that was 1 over x squared plus 1. So now we can use all of these derivatives, but I want you to remember to pay attention to a potential chain rule situation. So if I'm not taking the derivative where it's just x, I also have to add on that chain rule. Okay, so I hope that proofs helped. In the next video, we'll do some examples.